Welcome, ladies and gentlemen. So what I'd like to do is show you how to sketch a triangle based on the given information and then evaluate the other 6 trigonometric identities. So the main important thing is, well, whenever we're dealing with our trig functions, we know we're going to be using a right triangle. So what I'm going to do is I'm going to draw actually a right triangle for every single one of these here. OK. Now, we know we're dealing with right triangles. Now, the next important piece of information is we need to deal with, and I'm going to do one of them. I'm going to kind of do them all together for a little bit, and then I'll break them all up. The next thing is to identify, well, what are the important parts? What do we have? So remember, sine is, actually, let's just call, and then let's just pick an angle. Let's just call this theta. Doesn't really matter because we are kind of putting the sides in. So we have a right triangle. We have an angle. That's going to be our theta. And then we have a right angle. Now, remember, sine of theta equals opposite over hypotenuse. Now, remember, for each one of these, here is always going to be my hypotenuse, right, for every single one of my triangles that I just created. And this is always going to be my adjacent. And that's always going to be my opposite. Adjacent, opposite. Adjacent, opposite. So if I have opposite over hypotenuse, that means I know that the opposite side is 3, and my hypotenuse is 4. Okay? In this example, cotangent. Now, we need to remember, well, what exactly is cotangent? Well, we know tangent is opposite over adjacent. So cotangent is adjacent over opposite. So therefore, that's my adjacent side. That's my adjacent side. That's going to be my opposite side. And then secant, well, remember, cosine is adjacent over hypotenuse. Secant is going to be hypotenuse over adjacent. But we have a problem here, because as you can see, I don't see this as a fraction. I see this as a whole number. So what we need to do is rewrite this then now as a fraction. Now you can see that this is hypotenuse over adjacent. So therefore, that's going to be 1. And that's going to be 2. Now, before we can evaluate the 6 trigonometric functions, we need to figure out what are the missing lengths, right? So to do that, we need to use, again, Pythagorean theorem. So therefore, if that's 3 and 4 here, opposite over hypotenuse. So therefore, I'll just call this, we'll call all the missing lengths x. Actually, you know what? Let's call this b. Let's call the opposite sides b. Let's call these a, and let's call the hypotenuse c, just because I know everybody likes a, b, and c. So therefore, this is going to be a squared plus 3 squared equals 4 squared. A squared equal a squared plus 9 equals 16. A squared equals, subtract 9 is going to be 7. Square root. A equals the square root of 7. So the adjacent side is now going to be the square root of 7. Over here, I'm going to have 3 squared plus 2 squared equals c squared. 3 squared is 9 plus 2 squared is 4 equals c squared. That's going to be 13 equals c squared. Square root. So therefore, the hypotenuse in this case is going to be the square root of 13. And then in this one, I have 1 squared plus b squared equals 2 squared. 1 squared is 1, so subtract 1. So b squared equals 3. Square root. B equals the square root of 3. All right, so we got a lot of square roots in this case, which is perfectly fine. That just means we're going to be rationalizing the denominator. So I want to leave up the pink here, but unfortunately, I kind of ran out of some room. So I'm going to erase the Pythagorean theorem. But hopefully, you guys can see my example of how I was able to get to all of these. Now, let's go into the fun stuff of actually identifying the sine, cosine, and tangent. Now, hopefully, my other videos are in your notes. You know what the sine, cosine, and tangent is. So that's going to be helpful, because what we'll do is I will do sine, cosine, and tangent really quickly. And then we'll just do the reciprocals. Because remember, the reciprocal, or sine and cosecant, are just reciprocals of each other. So once you know sine, you just reciprocate it to find cosecant. So in this example here, sine of theta, remember, is opposite over adjacent. Opposite over hypotenuse. So that's going to be 3 over 4. Cosine of theta is the adjacent over hypotenuse. And tangent of theta is opposite over adjacent. So that's going to be 3 over the square root of 7. Now, it's important whenever we have a square root in our denominator, though, that we need to make sure that we rewrite that we rationalize the denominator. So I'm going to multiply by the square root of 7 on the top and the bottom. And therefore, I have a final answer of 3 square root of 7 divided by 7. So just be very careful. That's going to be our final answer here. Now, to go ahead and determine cosecant, I'm just going to flip sine. So therefore, that's going to be 4 over 3. To determine the secant of theta, that's just going to equal 4 over the square root of 7. Now, you can rationalize the denominator again. Or what you can just notice is once you kind of do this a lot, is you can pretty much figure out the answer here. And then for cotangent, it's just going to be reciprocal of this, which would be the square root of 7 divided by 3. OK, so now let's go over to the next example here, which again, I want to determine what sine of theta is. Sine of theta is going to be opposite over hypotenuse. So it's going to be 3 over the square root of 13. Again, remember, you can rationalize the denominator, or you have to simplify this. So therefore, I'm going to have 3 square root of 13 divided by 13. Cosine of theta is going to be adjacent over hypotenuse, so 3 over the square root of 13. Again, just remember in this case, you can rationalize the denominator like I did, or just kind of realize that the answer, why is my answer opposite over, that should be a 2. You can see that the answer is going to be exactly the same, but now with a 3 instead of a 2. So I just didn't decide to rationalize the denominator. I just simplified it. I still rationalized the denominator. I just did it in my head. Tangent is going to be opposite over adjacent, which in this case is pretty nice. That's going to be 2 over 3. So now cosecant is just going to be the reciprocal here. So I'm just going to rewrite the square root of 13 over 2. You could use the reciprocal of this, but then you'd have a radical in the denominator again. So just go back to this and write the reciprocal. The secant of theta, when we're doing the secant, is going to be the square root of 13 over 2. And the cotangent of theta, again, is just a reciprocal, which is going to be 3/2. All right, and now let's go and get to our last one here. And I'll try to go through this as quickly as possible. So again, we already know what secant. Oh, I already wrote those down. Oh, yeah. I could have saved myself some work, right? And already written those down. And well, let's do it for this one. So to do the sine, I know I'm going to be doing opposite over hypotenuse. So that's the square root of 3 over 2. The cosine of theta, well, we already know what secant is. Secant's 2 over 1. So we know cosine is going to be 1/2, or opposite over hypotenuse. So therefore, the tangent of theta is opposite over adjacent, square root of 3 over 1, which is just the square root of 3. The cosecant of theta is going to be the reciprocal of 2 over square root of 3 over 2. So that's going to be 2 over the square root of 3. I make sure I rationalize my denominator. And when I do that, I get 2 square root of 3 over 3. The secant is in our problem, which I should have done for the rest of these. So you can see that answer is just 2. And then the last one is cotangent of theta. So when doing cotangent of theta, that's going to be adjacent over opposite. So that's going to be 1 over the square root of 3. Rationalize the denominator. That gives me the square root of 3 over 3. So there you go, ladies and gentlemen. That is how you evaluate your 6 trigonometric functions when given a certain equation for an angle. Thanks. OK.